First question says that the triangle ABC is a right angle triangle at B, and the altitude from B is drawn to meet AC at D, and from D, perpendiculars are drawn to AB and BC again, meeting them at point X and Y respectively, right? So I have just drawn the figure. As you can see that this is the triangle ABC, this is 90 degree at B, right? So altitude from B is at AC, so this is also 90 degree, correct? Further, from D, two altitudes have been drawn, one to AB and the other meeting BC at Y. Further, it says that the ratio of AB and BC is 5:4, so we have to find the ratio of DX and DY. Clearly, there will be a lot of similar triangles will be formed because one angle obviously is 90 degree, the other angle we can easily identify. For example, if I want to find out that, say, this angle is say theta, this is 90 degree, then definitely this much angle would be 90 minus theta. So in triangle BBC, there are three angles. One is theta, the other is 90, and the third one is 90 minus theta. Now again, this entire angle is 90 degree. This much is 90 minus theta, but obvious this angle has to be theta, so that the sum of these two should make it 90 degree. Further, this 2 is a 90 degree, correct? Thereby, if this angle is theta, this is 90, then this angle has to be 90 minus theta. So clearly we can see that triangle, say ABC, this is similar to triangle, this would be BDC, and this is similar to triangle, it is ABC, so A is 90 minus theta. Here it would be ADB, yes, it would be ADB. These are the three similar triangles, right? Further, it is said that AB and BC, the ratio is AB and BC, the ratio is 5:4, and we need to find the ratio of DY and DX. Now clearly we have to focus on these two triangles. These two triangles are similar, then their corresponding height, corresponding angle bisector, corresponding altitude will also be in the same ratio as BD over AD or DC over DB, so and so forth, right? Now if I want to find the corresponding side, then this is BC and here it is AB. Now BC and AB, they are in the ratio 4:5. So corresponding altitude of this triangle and the corresponding altitude of this triangle will also be in the same ratio. Now the corresponding altitude of ADC is dy, right? So dy and dx, they will also be in the same ratio 4:5. We need to find the ratio dx is to dy. So obviously this ratio will get reversed. So dx over dy would be equal to 5:4. So option B becomes the right answer. Now in this question it says that there are two vertical wood poles of height 12 meter and 27 meter, and they are located 8 meter apart. So let's draw this scenario. So this is the first pole, so this is 8 and this is the second pole, right? So this is 12 meter, this is 27 meters. Now further it says that and this is also 8 meter. Further it says that if the shorter pole is chopped off at a distance 4 meter from the top, so this is the top, so from here it is chopped off, right? So this is 4. Now this much will become 8. So let me just remove this. At what distance from its base should the taller pole be chopped off to ensure that the distance between the top of the two poles remain the same? Before the shorter pole was chopped off, the distance between the top of the two poles was this, right? We want that after chopping off the larger pole, the distance should remain the same. So we can say that this should be the new distance and this two should be equal. In fact, it should become a parallelogram. Now why this is a parallelogram? Because these are two parallel lines, as well as these two poles are also parallel lines. So we can say that this is also parallel to this. So opposite sides are parallel. If the two pairs of the opposite sides are parallel, then definitely the diagram so formed is a parallelogram. And because of the virtue being a parallelogram, this diagram, we can say that the length of the opposite side should also become equal. So we can say that the top pole should also be chopped 4 meter away from the so the larger pole should be chopped 4 meter away from the top. And we have been asked about the distance between the tops of the two poles remain same. At what distance from its base should the taller pole be chopped off? So this is from the top. From the base, this would be the distance, which is nothing but 27 minus 4, which is equal to 23. So option D becomes the right answer. Very, very simple question. Everyone should have solved it, right? Now here the question says that there are three sides AB, BC and C of a triangle, and these sides are given as 7, 10 and 12 respectively, and AB is extended to D and the length of AD is 28. So we can just refer to the figure. This length AB is 7, AB is extended till D and the entire length is 28. So we can say that BD, this will be 21, correct? Similarly, BC is extended and the value of BE is 20 centimeters. So BE is 20 centimeter, BC is 10. So this will also be equal to 10. Similarly, CA is extended and the value of CF is 36. AC is already given to us as 12. So this much will be equal to 24. So we have to find the area of the smaller triangle vis-a-vis to the larger triangle, right? Now what we can do here is that let us assume that the area of the triangle ABC to be A. Now I'll be just joining BF. In this case, we'll just focus on the triangle CBF. Then we can say that the vertex is same and the base is in a straight line. So these two areas will be in the ratio of their base, and the base is FA and AC. So FA and AC are 24 and 12 respectively. So the ratio is 2:1. So we can say that if the area of this portion is A, then this area would be 2 times of A. Correct? The same logic will be applying to ADF. If you look at this triangle, then the vertex is same, that is F, and this length is 7 and this length is 21. So obviously the ratio is 1:3 and this area is 2A, then this will be 3 times of this, which is equal to 6 of A. Correct? And again, we can look at triangle FBE. In this triangle, F is the common vertex, BCE is the base in a straight line. So the ratio of area of triangle FBC and FCA will be in the ratio of their base. Both are 10. That means both the area will be equal. Here the area of this portion is 2A plus A, which is equal to 3 of A. So this area is also equal to 3 of A. Right? That is FCE. Now we are done with this. So we have to again join this. Let us join CD and focus on triangle ACD. In this triangle, C is the common vertex and the base are in the ratio 7:21, that is 1:3. So if the area is A here, then this area would be 3 of A. Correct? Again, focusing on triangle DBE, we can say that the base is same and the vertex is common, that is D. So this area is also equal to 3 of A. So we have figured out the area of the entire triangle DEF. And if we add them, then it's going to be 3 plus 2 plus 3, that is 6. 6 plus 6 is 12. 12 plus 6 is 18. So this area is 18A and this area we assume it to be A. So definitely the ratio would be A over 18A, which is nothing but 1:18. So option B becomes the right answer. The question is not difficult. The only thing is that you have to figure out that which portion you have to, what kind of construction you need to do, and applying this repeatedly, the same logic that if the vertex is common and the base are in the straight line, then both the areas are in the ratio of their base. Now in this question it says that we have to find the number of triangles which has integral sides such that all three sides are of different length, where R being the largest side and P being the smallest side, such that the perimeter is 27. So P plus Q plus R is the perimeter, which is equal to 27. And to ensure that the triangle is formed using the length PQ and R, we have to use the logic that the largest side should be less than the sum of the other two sides. Correct? So we can say that there is a limit for the maximum value of R. If I want to take the maximum value of the largest side of such triangle, then it cannot exceed half of it, right? Otherwise, this relation will not hold. For example, if I take the value of R to be 14, then P and Q together will be equal to 13. So no such triangle can be formed, right? So the largest possible value which R can take is 13. It cannot take more than that. So let us see that can we make triangle with sides 13 as the largest side. So the other two sides, the sum has to be 14, correct? So we have the possibility wherein I can take 12 2, right? I'm not taking 13 1 because I have to keep this relation intact, right? This will be the value of R, this will be the value of Q, and this will be the value of P, correct? Again, we can have 10 11 3, 13 11 3, 13 10 4, 13 9 5, 13 8 6, 13, 7. No, sorry. We can't take 13, 7, 7 because otherwise P and Q both will be equal. So taking 13 as the largest size, these are the triangles possible. Now again, if I fix the largest possible value of R to be say 12, then the sum of these two has to be 15, and none of these value will be more than 12. In fact, it cannot take the value 12 as well. So we can start with 11, 4, then 12, 10, 5, then 12, 9, 6, then 12, 8, 7. Right? Now further, if I take the largest possible value of R to be 11, in that case the sum has to be 16. Thereby we can take it as 10, 6, then 9, 7, then 8. 8 will not be considered, right? So only these two possible. Now further, if I consider the possible value of R to be 10, then the sum of these two has to be 17. So it will be 9 and 8. This is the only possibility. If I fix the largest possible value of the length to be say 9, then the sum of these two will be 18, and thereby to ensure this relation, I'll not be able to fix the value of Q and R. So from here we can say that no more such triangles can be formed. We can just count them. So here on counting we'll be getting 5 triangles. Here on counting we are getting 4 triangles. Here we are getting 2, and here we are getting 1. So we have to add them. This is 9 plus 3 is 12. So option A becomes the right answer. Now in this question it says that the area of the triangle is given to us, and we need to find, and if the minimum possible perimeter is P, then we need to find the value of P square. Now it's quite obvious that the perimeter will be minimum when the triangle is symmetrical. Now the most symmetrical triangle which we can have is equilateral triangle, right? So in the case of equilateral triangle only, this is possible that the perimeter would be minimum for the given value of area. So let us assume that the A is the side of the equilateral triangle, then the area would be root 3 by 4 A square, which is equal to 8 root of 3. So this will go out. Value of A square will be 72. So the value of A would be 6 root of 2. So the perimeter P would be what? 3 times of A, which is nothing but 18 root of 2. Correct? But we have to find the value of P square. So it will be 18 root 2 whole square, which comes out to be 324 into 2, or 648. So 648 becomes the right answer. Very simple question, easy question, everyone can solve it. Now here the question says that a triangle ABC is given, and these are the 3 points on these sides. So let us draw this triangle. If I have the triangle ABC like this, so this is A, this is B, and this is C. P is a point on AB, right? Say P is point on AB, Q is a point on BC, and R is a point on AC. Further it says that BQ, this is equal to PQ. So we have to join P and Q also. These two lengths are equal. So in this triangle BQP, we can say that these two angles will be equal, right? Let us name them as alpha. So both the angles will be alpha. Similarly, it says that QC and QR are equal. So QC is equal to QR. So again, in the triangle CQR, these two angles will be equal because this is an isosceles triangle. So let us assume that this is beta and this is also beta. And we have been given that this angle is 75 degree. We have been asked about PQR. We have to get this value. Let us assume this to be theta. Now it is quite clear that if you look at triangle ABC, then sum of this angle plus this should be equal to 180 degrees, right? Or we can say that alpha plus beta plus 75 should be equal to 180 degrees. So clearly alpha plus beta will be equal to 105 degrees, right? Now in the triangle PBQ, this angle, if I want to find in terms of alpha, then this would be equal to 180 minus 2 times of alpha, because sum of all the 3 angles in this triangle would be 180 degree. Similarly, this angle would be equal to 180 degree minus 2 of beta. Further, if I add all these 3 angles, then it has to be equal. Then it has to be 180 degree. So let us do that. So it will be 180 minus 2 of alpha plus 180 minus 2 of beta plus of theta. This angle should be equal to 180 degree. Right? Now we can say that this we can get rid of, and 2 times of this will be 180 minus 2 times of alpha plus beta plus of theta is equal to 0. Now this is equal to 105. So it is 180 minus 2 into 105 is 210 plus of theta is equal to 0. or the value of theta would be 30 degrees. So the answer for this question is 30. Simple question, everyone can solve. You just need to identify that since these lengths are given, so obviously the triangles of form would be an isosceles triangle, and once it's an isosceles triangle, question is talking about the angle. So we have to take this process wherein the angles get equal for the sides which are equal in the isosceles triangle. Now let's take the next question. The similar kind of question we have already done a couple of question back. It says that we have to find the number of distinct triangles which has integral value side and the parameter is 14. So let us assume that the sides are A, B and C. So A plus B plus C, this has to be equal to 14. And let us assume that C is the largest side. So obviously C cannot be more than half of it. In fact, it cannot be equal to half of it as well. It has to be less than half of the total perimeter. Then only this relation is valid, that is the largest side is less than the sum of the other two sides for triangle to be possible. So the largest possible value of C which we can take is 6, and if I take the value of say C A B C to be 6, then the sum of these two has to be 8. So we can take 6 2, we can take 5 3, right? We are taking both the values to be 6 because we have not been given that all the three sides should be different. The sides can be equal. The only thing is that we have to find distinct triangles. Correct? And 4 4. So these are the three triangles possible. 6 3 5 is not possible. The reason being that is already been counted, right? Because if the three sides are 6 5 and 3, in which order we are writing, it will not make it a distinct triangle. So that's the reason I'm not taking 6 3 and 5, because it is already been counted here. Now let us fix the largest possible value of C to be 5. In this case, the sum of these two has to be 9. So let us start with 5, and this value will be 4. I don't think that any other triangle is possible because it will be 5 4 5 something, right? So it's not going to help us. Now if I put the largest value of C to be 4, then even if I take 4 4 for all the three, the sum is not equal to 14. So what we have found here is that these are the only triangles possible. So if I count them, so it will be 1 2 3 4. The answer for this question is option B. Now in this question it says that PQ and RS, they are parallel, and we have been given the angle this to be 130 degree and this angle to be 110, and we need to find this angle, right? That is be theta. So let's do the needful. Now one thing is sure, that if this angle is 110, let us take these two parallel lines and this as the transversal line. So if this is 110, then definitely this angle would be such that the sum of these two should make it 180 degree, correct? So this would be equal to 70 degree. Similarly, I'll consider this transversal line. So this angle and this angle, in fact, even if we don't consider transversal, just consider this. If this is 130 degree, then this angle would be 180 minus 130, which comes out to be 50 degree. Now focus on this triangle ABC. There are three angles and their sum should be equal to 180 degrees. So 50 plus 70 is 120, plus of theta should be equal to 180. So the value of theta is 60 degree, and 60 is the answer for this question. Let's take question number 9. Here it says that A and B are standing on an opposite bank of a river, and at a particular moment they observe the angle of elevation of top of the ship sailing on the river to be 30 and 60 respectively. Now if the height is given to be 30 meter height of the ship, then what is the distance between AB? So we have to draw the simple diagram. It will look like this, that this is the ship, this is the height, which is 30 meter, correct? And at one point it is 30 degree, and on the other side of the bank it is 60 degree. So we have to find the length of AB. It's quite simple. The triangles are 30 60 90 triangles. So this is 90 degree, this will be 30 degree, correct? And this will be 60 degree, because the sum of all the three angles in a triangle has to be 180 degree. Now if this is 30, which is opposite 30 degree, then opposite 60 degree, this has to be root 3 times of 30, right? I'm applying the logic that if the triangle has an angle 30 60 and 90 degree, then the side opposite to 30 degree 60 degree and 90 degree, they are in this particular ratio. So side opposite to 30 in the triangle PAD is 30 meter, then side opposite to 60 would be root 3 times of it. Similarly in this, side opposite to 60 is this, so side opposite to 30 would be 30 divided by root of 3. So the total value AB has to be 30 root of 3 plus this is 30 by root of 3. So we can write it as 3 into 10 by root of 3, so that this will get cancelled out. So it is 30 root 3 plus 10 root of 3, which makes it 40 root of 3. So option B becomes the right answer. Now let's take this question. This is a moderate level of question. You have to just apply some basic idea of number system also to get to the answer. Here it says that in a triangular park PQR, the length of PR is given. So let us draw the triangle, assuming that this is PQR, P, Q, and R, right? So QR, this length is known to us. The length of the side PR is the square of a natural number, and the length of PQ is an integral power of 3. So length of PQ is integral power of 3. So let us assume it to be 3 to the power x, correct? And this is square of some natural number. Also, it says that the length of PR, this is 1/3 the length of PQ, correct? I think I have mistakenly put this length here. PQ should be here. It says that PQ is an integral power of 3. So this is 3 to the power x, and this is some square of some natural number. And this is 1/3 of this. So obviously this will be what? 3 to the power x minus 1, right? Because 1/3 of 3 to the power x is nothing but 3 to the power x into 3 to the power minus 1, which comes out to be 3 to the power x minus 1, correct? Now for the triangle to be possible, if I take the sum of any two, it should be greater than the third, right? So let us assume that the sum of these two, for the triangle to be possible, I'm taking these two sums should be greater than the third. So it should be 3 to the power x minus 1 plus 312 should be greater than 3 to the power x, right? Or we can say that 3 to the power x minus 3 to the power x minus 1 should be less than 312. I'm taking 3 to the power x minus 1 as common, so it will be 3 minus 1 less than 312. So this is 2, so it will get cancelled out, so it will be 100 and 156, right? Now 3 to the power something is less than 156. We know that 3 to the power 1 is 3, 3 to the power 2 will be 9, 3 to the power 3 will be 27, 3 to the power 4 will be 81, and 3 to the power 5 is 243. So if it is 3 to the power 5, then this is 243, which will exceed this. We have to get less than that. So this fits best, right? So 3 to the power 4 is 81. So we can say that x minus 1 is nothing but 4, or the value of x is equal to 5. So this side is 243 because 3 to the power 5 is 243 and 3 to the power 4 is 81, which is a perfect square as well. So everything is adjusted, whatever the conditions are given. So these are the three sides, and we have been asked about the perimeter. So we have to add 81, 243 and 312. So I'll just take the help of calculators. So 312 to 243 plus 81 comes out to be 636. So option A becomes the right answer.